Welcome to my projectbazaar.com. Now we discuss about the product coding visual features extracted from video sequences. Now we discuss the abstract for the process. Visual features are successfully exploited in several applications, example visual search, object recognition and tracking, etc. Due to their ability to efficiently represent image content, several visual analysis tasks require features to be transmitted over a bandwidth limited network, thus calling for coding technique to reduce the required bit budget while attaining a target level of efficiency. In this paper, we propose for the first time a coding architecture designed for local feature, example shift surf, extracted from video sequence to achieve high coding efficiency. We exploit both spatial and temporal features by means of in-frame and inter-frame, that is the intraframe and the interframe coding modules. In addition, we propose a coding mode decision based on rate distribution optimization. The proposed coding scheme for can be conveniently adapted to implement the analyze then compress, that is ATM, in the context of visual sensor networks. That is, set of visual features are extracted from video frames encoded at remote node and finally transmitted to a central controller that performs visual analysis. Now we discuss the flow diagram for the process. At first, the input video is taken from the dataset. After getting the input video from the dataset, the video is converted into the number of frames. The frame is nothing but the sequence of image is extracted from the single video. After the frame is extracted from the video, the frames are undergoing for the process of encoding. The encoding is nothing but the encryption. The encoding is using the H.264 by AVC coding. After the encoding, the encoded frames are undergoing for the process of transformation. In the transformation, we use the KLT transformation method for the transformation. After the transformation, the transformed frames are undergoing for the process of quantization. After the quantization, the decoding is undertaken. The decoding is nothing but the decryption. In the decryption part, we have to extract the feature from the all frames. The feature extraction method we have used in this process is shift feature. After extracting the shift feature from the frames, the feature extraction from the frames is undergoing for the process of classification. The classification, the test feature as well as the train feature undergoing for the classification. After the classification, as per the classification result, the frames are retrieved from the database. The database consists of the test feature as well as the train feature data. The retrieved frames are the frames which are relevant to the sequence of the frames which have we extracted from the input video. Now we discuss the initial running procedure for the process. At first, select the main_GUI.m file and right click in that file, then select the third option, that is run. Now the initial guide window was opened. In that you can see the several buttons in the right side. These are known as the push buttons. Then these two display units are represented as an axis. This one is the axis 1 and this one is the axis 2. Now click the button which is similar to the folder. Now some of the folders are open in front of you. Select the folder dataset. After selecting the dataset, you can see the dataset video and select the video from the folder dataset. After selecting the video from the dataset, the selected video is shown in the axis 1 with the title original video. Then the frame conversion button is enabled. Now click the button frame conversion. After clicking the button frame conversion, the video is converted into the number of frames. The frame is nothing but the sequence of image which is taken from the single video. Now there are 50 frames are available in this video. Then click the button encryption. After clicking the button encryption, the encrypted form of the image, that is the encrypted form of the each and every frame, is shown in the axis 2 with the title encrypted image. The encrypted frame number is shown in the top of the video. Now the dialog box, that is the message box, is opened. Video is encrypted. Then click the button data embed. After clicking the button data embed, the data embedding frame will be shown in the axis 2. Then the embedded frame will be shown in the top. Now the message box was opened. Data is embedded. Now click the button decrypt. After clicking the button decrypt, the decrypted videos are found in the axis 2, and the transformation and quantization are also for the decryption. Now the decrypted video is plotted in the axis 2. Now the message box is done. Video is decrypted. Then click the button feature extraction. After clicking the button feature extraction, the feature point of the frame is extracted. These two images are shown for the feature extraction. The feature points are shown in this figure 1 and the figure 2. Now click the button next. After clicking the button next, the new guide window was opened. In that you can see the two axes and one button, that is retrieve. Now click the button retrieve. You can select the any one frame from the frame conversion. After the selecting, the corresponding video is running in the axis 2 with the title retrieved images. Thank you.